Hello, everyone, and welcome back to Thermal Engineering Concept and the Principle. This is Professor Ali Tarrad, who will accompany you through some other applications of heat transfer modes in technology. We have mentioned something about the technological applications of heat transfer modes in the previous section from part 2. And let us introduce more applications during the present video. So let us go. The objectives of the present video is to describe some other applications of heat transfer modes. First, we will pass through heat exchangers types and then move to some industrial applications such as water chiller, which produces chilled water to be used for utilities. And finally, we will go through some introduction for the solar energy. Let us talk about heat exchangers, and they are used in almost most of the thermal applications in industry. And the most popular one is the shell and the tube heat exchanger. And this heat exchanger composes of a bundle of a tube inserted inside external shell where heat transfer exchange occurs between the flow inside the tubes and the flow outside the tubes. And these photos show the internal construction of these heat exchangers. Of course, if you look at the first photo to the left-hand side, it is for a clean heat exchanger. And during using heat exchangers, usually we expect for these heat exchangers to be uh, a sort of contamination or block. And the photo on the right hand side showed a severe impact of the process in petrochemical on these tubes. And it seems to be that these tubes are completely blocked, so there is no possibility for heat transfer to be exchanged. Then this case of heat exchanger, we have to stop the utility, take it off and clean it, and then we will return it back to the as I mentioned, that the bundle of tubes is inserted inside an external shell. And this photo shows sort of corroded tube bundle. And it seems that these tubes are out of use now. And if you look at these tubes are spaced by a baffle that is a plate to hold these tubes. And we have the baffle here is clear. It is a plate that has some holes to ease the passage of tubes. Baffles in shell and the tube heat exchangers. Baffles is composed of or made of a piece of a plate that is containing holes to um, ease or to allow the passage of tubes through this plate. And in general, the baffle has many advantages in heat exchanger construction. And we are talking about the shell and the tube heat exchanger. First, these baffles can control the heat transfer coefficient on the shell side. And at the same time, they control the pressure drop on the shell side. If you reduce the spaces between these baffles, then you are increasing the velocity of the stream that is passing on the shell side. In this effect, you are improving heat transfer, but at the same time, you are increasing the pressure drop on the shell side. Therefore, a compromise should be reached for the spacing between these baffles. Baffles can build a real cross flow between the two streams, the one which is passing on the shell side and the other stream which is passing through the tube side. So finally, the mechanical advantage of these baffles is to hold these tubes, to support them as long as you are building a heat exchanger. And that means it gives a sort of support for the tubes to be in straight between the tube sheets on both sides of the heat exchanger. So if we control the baffle, then we have to think about a baffle cut. The baffle cut usually is ranged between 15 to 45% of the inner shell diameter. And the choice of the baffle cut depend on the nature of the fluid on the shell side and on the purpose of that heat exchanger, such as cooling, heating, or condensation. Now, let us describe the flow pattern on the shell side. So if we consider a tube bundle composed of 12 tubes with external flow outside these tubes. And let us take one of these tubes in a shell, just for illustration, to see how the flow pattern on the shell side and tube side will be. So if we have two fluids, one on the shell side and the other on the tube side, then this uh, animated illustration shows how the fluid flows on both sides. The blue one is for the shell side, and the red one inside the tubes is illustrated for the tube size. And if you look between these what we call it, the flow pattern, there is a baffle that is distributed in equal distance on the shell side, and the flow on the shell side will be perpendicular to the flow inside the tubes. That's what we call it, a real cross flow. The second type of heat exchangers is so-called the double pipe heat exchanger. And in general, it is an easy construction for this type of heat exchangers, that we have two tubes, one inside another. The external is called annulus, and the internal is usually called the inner tube. And the flow of both fluids are in counterflow, and it could pass from one side and leave at the other side at the same time of the tube side. So we have um, heat exchange between these fluids. As you can see here in this illustrated figure, that these flows are continuous on both sides and there is no mixing between them. And at the same time, if you look at the right hand side, we have an illustration for how the fluid is passing through the annulus side, which is passing from one side to another. So this is a sort of heat exchangers with low heat transfer load, and these we call it uh, layout of these tubes can be made in multi, uh, either series or parallel flow to achieve a required heat transfer rate in an industrial application. Other types of heat exchangers. We have the plate and the frame heat exchanger. It is also called a compact heat exchanger because we have a large surface area per unit volume, and we can save sort of space, and at the same time they are efficient in heat transfer exchange between the two fluids. And it is called a plate because it is made of a number of plates separated by fluids on the both sides, and these can achieve high efficient heat transfer. They may be used in industrial, uh, food industry, uh, dairy industry, uh, also in ice cream industry. They are using this type of heat exchangers. And the fourth type is the air cooled, and it is called air cooled because usually on the external side, air is used to cool down these heat exchangers, and they are used widely in air conditioning units if you have a window type, and they may be used in the design of condensing unit, which is outside the space, and in water chiller for the air cooled type, uh, it is used there as well. We have another type which is specified for low heat transfer load, and these are called immersion coil, which composed of an external drum where a fluid passing through it, and a tube coil made as coil where uh, maybe refrigerant passes through that for the purpose of um, evaporation, and water can give energy to the refrigerant to evaporate. So it may be a work as evaporator in the part of a cooling unit. The other application is water chillers, and these equipment called water chillers because in effect, we are cooling water to low temperatures. And when we call a water as a chilled water, then we are referring to a temperature which is as low as 4 to 5 degrees centigrade. And in these photos, water chillers, which are using a condensing unit from the type of air cooled. And we call it air cooled because we have the surface fluid, air, takes the heat to condense the refrigerant which is circulated in a condenser. That means water chiller is a thermal cycle composed of many components, and we are going to describe that in the second, in the next slide. But we have to think about the range of temperature. What we have, the temperature range for chilled water is between 6 to 12 or 5 to 11. And typical values is between 12 and 7. And that means the water enters the chiller at 12 and leave it at uh, 7 degree centigrade. Now, let us think about the water chiller categories. As I mentioned in the previous slide, that there is a sort of water cooled and air cooled. So, air cooled uh, water chiller is referred to the condensing unit, which uses air for condensation. So, it composes of heat exchanger shell and tube, uh, air cooled condenser, compressor, and expansion valve. And in this unit, the output is a cold water with delta T water ranged between 5 to 6 degree Celsius. And again, it is called air cooled chiller because we are using air for the condensation unit or the condensing unit. Water cooled chillers, and these chillers require the heat exchanger, which is a sort of shell and tube, and the water to be supplied from a cooling tower. And in that effect, the refrigerant, which is circulated in the cycle, passes through the heat exchanger, such as shell and tube, and cold water is usually supplied from a cooling tower. Then the water is heated as it extracts the energy from the refrigerant and return back to the cooling tower to achieve the cooling and return back to the uh, condenser. In that sense, we will get a steady state conditions and continuous operation. And maximum delta T of water is around 12 degree centigrade. And finally, let us go to describe solar energy. And solar energy is usually used for heating purposes on the top of buildings. Sort of solar panels are fixed there, extract energy, and then store. And sometimes they are used directly to get hot water. We may see in these videos that it could be installed at the top of building for heating purposes, or they may be made in a field of solar panel to produce electricity. And this is considered as renewable energy, clean energy, cheap, and so on. Therefore, solar energy mainly occurs when energy is extracted from the sun and then used to heat up water, for example, or they may be used to produce electricity. As engineer, usually we hear the technical word solar panel. What is the solar panel? The solar panel is a semiconductor material such as silicon, uh, is used to produce cells, and these are uh, installed inside an external frame with glass. And we have here a semiconductor material, and these materials have sort of conductivity between conductors such as metals and non-conductor or insulators. And these materials are used to produce a cell that has the ability to uh, extract energy from the uh, sunlight and uh, charge it for a sort of storage part of the system to get electricity stored, or as I said, we may use it directly to heat up water. And if you have a look at this figure, this is just to show you that from the sunlight, the panel at the top of the building extract energy and then charge it to a storage where it can be used for uh, during the night, maybe where there is no sun as well, and may be used during the day for producing electricity or hot water. We have many other applications, but there is no room to talk about all of them. I'm going just to mention some of them in this slide. We have the satellite and the space sciences. They are using the heat transfer modes. We have casting, metal casting, which are used widely in industry. We have also the combustion engine production, and most parts of this engine are produced by casting as well. We have the electronic equipment, starting from domestic and ending at the industrial sites. We have in the medical equipment side, such as furnaces, they are using these furnaces, especially the dentist. And we have the air conditioning and refrigeration system for heating or cooling. We have also water treatment and purification um, to produce drinking water as well. Heat transfer is there. And finally, this is an application for food industry where heat transfer is there. So wherever there is a sort of technological applications, then you will find heat transfer modes. Don't forget, it is heat transfer modes: conduction, convection, and radiation. Now we reached the last part of this video. Uh, we gave some applications and technology for heat transfer, and I think you have enjoyed this seminar. And as a closure, we talked about different applications and types of heat exchangers: Kalan tube, double pipe, air cooled, plate and the frame, and immersion coils, which are used in industry. We talked about water chillers categories: air cooled and water cooled, and how these chillers are operating. And finally, we gave we call it a short introduction to solar energy. And I hope that you enjoyed the um, lecture, and see you next time. Goodbye.